26 with SSV network and some other projects that are building on top of SSV network. This is community call number 26, and we are here to learn about what SSV network is, how it fits into general distributed validator technology, kind of compare it to previous calls that we have done, and figure out what they're all about and what the progress on their roadmap is. From SSV, can you guys introduce yourselves real quick?
Sure. I'm Alan from SSV. Been in the crypto space, the blockchain space for quite a while, since 2013. And we're heavily involved in staking in general and obviously DVT the past 2 years.
Nice. And from the team, is anybody else from Ariel is here from and
Hey guys, Ariel from SSV, leading the product here. Excited to be here.
Awesome. So it's great to have you guys here. EthStaker in general tries to promote the health of the beacon chain, and so we are here to help people get sort of familiar with the different options out there and see what's coming up and coming and what they can help out with. And we'll talk about how stakers in general can get involved in SSV. So Alan, do you want to introduce sort of what SSV is, how it came onto the scene, and what DVT does for the ecosystem in general?
Sure. I'm just sharing my screen, kind of to use the presentation to kind of go through a bit of the topics you've raised and maybe a few more. Let me know once you can see it.
I can see it. Remy, is it good to go on the? Okay, go ahead.
Perfect. So what SSV does is obviously SSV develops DVT, and we'll get to it. But really, what we like to look at ourselves at is a distributed infrastructure for Ethereum staking, and specifically Ethereum staking applications. With kind of the grand vision, I think that really Ethereum security should really be in the hands of as many people or as many entities or as many node operators as we can, but vulnerable to none of them. And that's really, I would say, kind of the intersection of what DVT enables to do, in a few words. And so I guess most people know kind of the problems we're facing or the challenges we're facing in Ethereum. Obviously, staking centralization is a big risk factor. There's very few entities controlling very big amounts in percentage of stake, and that's problematic for several reasons. Both, of course, for the staking they manage or the assets they're managing, but also the bigger they are, there's a systemic risk on Ethereum and obviously the entire Ethereum ecosystem, including the people in it, specifically because of how staking on Ethereum works. And also kind of in extension to that, censorship or regulatory risks are coming along as well. And so kind of looking at the landscape, what we achieved from 2 years ago, since Genesis, up until today, there's a lot of things we've achieved as a community, but there's also a lot of challenges going forward. And let me see. And so kind of, looking at the future and what we want to look at in terms of, trying to solve those challenges. On the one hand, we have DVT technology. And on the other hand, obviously, we have solo stakers. Both of those things, the bigger they are, I think, reduces those kind of previous risks we've talked about. Each one has its own challenges. I think if we're looking at kind of the dream scenario, in everyone's mind, we would have looked at, one validator per entity, and then we would have 500,000 entities running different validators. Of course, in reality, that's very, very challenging. And so kind of the combination, I would say, of both DVT and solo stakers, if we need to look at kind of what our goal as an Ethereum community in the next 3 years, I would say we want to have those two things reach at least 67% of the stake, 2/3 basically of the Ethereum stake. That's, I think, a real goal we should have as an Ethereum community. And I think Divity plays a major role in it. So I will go through it quickly. I would say by now, I think most people know what Divity is, but Divity is the distributed Ethereum validator technology. The idea is to take an Ethereum validator and be able to split it up into independent operators. Those operators coordinate with one another using a consensus protocol, and then with threshold signatures, they are able to execute duties for the validator in a distributed way. And that's really kind of the heart of the technology. And where DVT fits kind of in the general Ethereum landscape is we generally see Ethereum kind of expanding beyond the L1 realm. So you'll have obviously L2s, which have been talked about for quite a while, enable you to spend less and have more scale. We have kind of extensions towards middleware like NED Boost enables you validators to earn more and kind of have a much more sophisticated market for transactions. And Divity really fits kind of down there in terms of being able to decentralize Ethereum, will help decentralize Ethereum as a component, infrastructural component for Ethereum itself, basically. And so the kind of core component of that is a Divity cluster. A Divity cluster can be several node operators coming together and somebody initiating some kind of a key generation ceremony and then depositing 32 ETH. And those that participate within that cluster are able to basically execute duties on behalf of that validator. With kind of the idea of minimizing slashing risk and downtime. A new concept with DVT is layered resilience and diversity. You can layer in several degrees of diversity and resilience because you have different components you can play with and have each cluster member having its own setup. So for example, different clients, different ISPs, different data centers, and so different operating systems and so on and so forth. And of course, fault tolerance. If one of those cluster members fail, the others can recuperate and continue working. It's one cluster member failure doesn't mean the failure of the actual validator. That's kind of the basic idea.
Is there a number for that, Alan? The fault tolerance? How many of the cluster need to be online for it to work?
So we generally, when we're talking about fault tolerance, we're talking about 3F plus 1, and F is the variable. So you can have, if F equals 1, you can have 4 operators, out of which 3 need to be online to operate. If you bump it up to 2, then you have 7 operators, out of which 5 can be need to be online, and so on and so forth. The more you have, obviously, the bigger the threshold in terms of fault tolerance becomes. And so depending on your application, if you're at-home staker and you want to use DVT, you might be okay with just 4 operators. If you're a larger staking provider, you might want to bump it up into 7 or 10 even, just to have that extra fault tolerance and kind of robustness built in.
Nice.
Yeah, go ahead.
I just said nice.
And so a bit about us. We've been in this space for quite a while. Been doing a lot of different things. Around 40 people in the SSV project. Been running a testnet for more than 18 months with 100 plus different service providers, staking providers from around the world. And in general, being very focused on Ethereum staking ever since the beginning of 2020. So kind of year before Genesis and all the way from that. So our kind of goal or mission, I would say, is to take kind of the existing validator stack and being able to transition towards not just a single cluster setup, but really we're looking at a multi-cluster or DVT network type of setup. Where you have a bunch of different operators which can participate all at once in several different clusters. That kind of creates interdependability between them. And so if you look at it, you'll see just a huge mesh of different node operators And the bigger that meshes with more connectivity between it, the bigger the resilience of that network is, because if one of them fails, if one of those operators fail, because it's very well connected to others, the others can pick it up and continue working. That's where fault tolerance comes into play. Rather than if you have like a very kind of segmented space, you could have major failures. Like if you have one cluster with 4 operators running 30,000 validators, it's not as good as having 10,000 or 10,000 clusters running 3 validators each, right? Just this interconnectivity and interdependability is really what can make it really robust, where you can have like recuperate different scenarios of fault tolerance or faulty nodes, sorry. And so that's kind of where we're aiming. That's kind of where we've developing from really the get-go, the idea of this kind of multi-cluster DVT type of network. And in that, there's a bunch of different things happening. So we're a contract-friendly and contract-based type of protocol with data availability on-chain. The DVT protocol we're developing really has no coordination built in it, so you can really run a validator in a few minutes. And one of the reasons why we did that is to enable projects like Friends and Stater to build on top of it, because if you really need a heavy dose of manual coordination, it becomes very hard to develop different types of protocol, different types of services, and so on. And the variety of different things you can do on it is quite wide. You can have solo stakers going in and running their own nodes. You can have applications, you can have institutional services, and so on. And so there's a bunch of different things you can kind of work on and so on.
In response,
yeah.
In response to that, who would you say is the target audience for SSV and DVT technology? Is it the solo staker? Is it institutional stakers? Is it both? Is it one more than the other?
For the most part, we are focusing on developers. So and the variety goes from there. So you can have like a hardcore, decentralized focus type of service, all the way to an institutional staking service. I think that variety is important. If kind of the goal and the mission is to help Ethereum stay decentralized, then you have to have that wide approach to different projects, because otherwise you'll segment different types of stakers, and then you'll have to have 15 different solutions in order to accomplish what one type of solution can achieve. I think, again, the mission is we want to avoid 6 entities controlling more than 50% of the stake. So if we can decentralize that, and by decentralizing it, it means that you have to be approachable by a variety of different use cases for staking, because otherwise it's not really possible.
Cool.
Yeah. And that's really kind of also the last part. I mean, it needs to be reusable, and by reusable, it means somebody who can walk into our website and set up a validator without in minutes. It doesn't need to know the operators. It doesn't need to set up with a group of friends which are super techy and so on and so forth. Basically lowering the barrier for anyone who wants to use DVT, basically.
I have a question for the previous slide, if you can go back. Maybe I missed something, but for the single cluster, based on the visualization, it looks like the client diversity is there, but the only thing that matches on all stacks is the SSV integration. So what are the risks of having the same SSV integration in all clusters, or like on all the stacks? Because now you diversified the clients, but still have the same SSV integration on all of them.
Yeah, that's definitely a valid point. So it's the same risk of having one client for Ethereum. So one of the things we did was, and that actually cost us a lot of time, is to, if you want to be, like, if the goal is to be obviously multi-client type of protocol, right? That's kind of where you're alluding to, right? If you have multiple clients developing on a protocol, you have client diversity, and then you don't need to trust one client or one project and so on. But in order to achieve that, you need to have a very good and detailed spec for your protocol, because otherwise it's very, very hard to create another client. or several clients for that matter. One of the key things that Ethereum did the past few years is to adopt a really efficient way of describing the protocol in a specification. So you could have 5 or 6 or 7 or 8 different clients building Ethereum Beacon nodes, right? And so that was our approach since the beginning of last year. And so SSV, we as a project, we've invested a lot in that specifications exactly. So we have a very, very detailed and well-tested spec for SSV. And one of the key things in our maybe New Year's resolution was to have a second client by the end of this year. And so we actually already started this. I can't really name the project that will likely will do that. But because we have a good spec, it enables them to develop a client fairly fast. And so this image hopefully will change dramatically in the next year. And so you have multiple clients, yeah.
What's the worst case scenario if, let's say, the single implementation has a bug?
The worst case scenario is the operators stop communicating with one another and you go offline. Slashing can't really occur because you have a remote signer in all of those implementations. So if you can't really sign something which is slashable, you could be offline. That's kind of the problem, which is a big problem in of its own. Yeah.
Mm-hmm. Okay, thank you.
Yeah.
How does another client work? Does it like fork off of SSV, or does it build on?
Oh no, it's a whole no. You don't want to fork it because then you inherit all of the problems if you do have any. It's a whole clean sheet development, but because it has a spec to test against, it can develop quickly and it can be sure that it's aligned with the actual spec of the protocol. So you have a separation between, if you go to our GitHub today, you'll see 2 different projects. You'll see the spec, which is one team working on it, and you'll have the client, which is another team working on it. And the spec team or rather the client team follows the spec. So they develop and develop and develop, but ultimately they need to test against the spec. And the spec coverage is what really gives the guarantees that if you have 2 clients or even just 1 client, it actually follows what you designed it to do. Otherwise, you can continue developing your client, but you could, for example, create a non-spec feature because you don't have any reference. You would never know that. And so that step was really important. It took us about 8 months to do that because we originally started without a spec. And we quickly realized that if we want to be a multi-client type of protocol, and DVT needs to be a multi-client type of protocol, then you have to have that component.
So the difference between, say, a client that follows your spec in like an existing competitor is just that they don't, an existing competitor like Obol wouldn't follow the spec at this moment. So is it possible that that competitor, what we see as competitors right now, like SSV and Obol, become interoperable clients?
On the face of it, yeah. I mean, the SSV spec is out there. Anyone who's willing to build something which is compatible, you wouldn't know the difference. Like if you tomorrow develop, take the Charon client from Obol and make the adoptions, and follow the spec, then other network participant will never know the difference. It's exactly the same spec, right? You're sending and receiving the same messages. And so that's the whole idea of that spec. Again, kind of reference, it's not like we reinvented the wheel, right? I mean, Ethereum has been doing it for years now, very successfully. And the reason why is exactly that, because if you want to have multi-clients, you have to have it. Otherwise, it's a mess. It's very hard to, if you look at a client code, it's a very, very big code base. If another team now without a spec needs to follow that, it's a very, very difficult process. And so yeah, that's the main reason.
Cool. That brings me to a question that I have, which is, Obol is the main peer that everybody knows about, like SSV and Obol. What would you say are differences that you see between these 2 implementations of DVT?
Yeah. So other than the spec, I think exactly the slide you're looking at. So our approach is to go with a multi-cluster DVT network, with the idea that if you create this big mesh with thousands and even tens of thousands of clusters, by doing that, the more interconnected that mesh is, the stronger your protocol is in terms of fault tolerance, in terms of isolating issues and not letting them influence the rest of the network. So again, if I go back to the example, Obol is really good at having one cluster with 30,000 validators, for example, or 10,000 validators. It's very, very good at it. If you look at the documentation, you could very quickly create 10,000 validators on a specific cluster. The problem with that is that you're putting all of your eggs in one basket. What we're suggesting is not having one cluster with 10,000 validators, but having maybe 5,000 clusters with 2 validators. And that's a very different approach. And the difference between the clusters doesn't have to be the entire operator set. Like you can switch out, let's say you have like 7 or 10 cluster members, right? If you switch one, you have a new cluster because you've put somebody out, you've introduced another operator. If you do that with enough permutations, just think of the degree of change you're making, and then it's not really obvious that if you fail one specific operator, you take down 10,000 validators. With Obol, if you have like, let's say 4 operators per cluster, if you can attack 2 of them, you're basically down. But if you have 5,000 clusters, in order to now attack 10,000 validators, you need to attack much more operators. And so it's a very different way, I would say, about thinking about things. So that's one major difference. The other one is that...
Does it come with... is it more efficient, or what are the differences if you go a single cluster?
So again, it depends on your spec. It depends on how you build it. So from the ground up, we've built it as a multi-cluster type of node, and so one node on SSV can handle 1,000, 2,000, 3,000 clusters, right? I mean, because it's on the same mesh and it can just communicate with other operators. With Obol, what you'll have to do is, at least currently, is that for each cluster, you need to run another client, another Charon client. And so, if you think about it, the waste there in terms of resources, money, DevOps, I mean, it's a big nightmare. Like, again, if you have 5,000 clusters, just imagine maintaining 5,000 different Charon nodes. So it's a pretty...
so it's a trade-off of having... is it just performance, or what are the trade-offs going?
Oh, we don't see any difference in performance. I mean, we're measuring performance very closely. If you set up a good cluster on SSV, you'll be running close to 100% attestation rate, for example. And as you guys know, and that's on Prater, right? So on Prater, obviously performances are a bit degraded in comparison to mainnet. And you'll see the same exact effectiveness as you'll run just a regular validator. There's not a lot of difference in that regard. But I think in terms of setup and just the easiness of setting 5,000 clusters, if you have that mesh like we've built it, it's a much easier way to do that. Also, couple that with the fact that we're using data availability on chain. So when you register a validator, it's on chain. So you have a central, or not central, but you have like a blockchain, Ethereum blockchain, synchronizing between all of those nodes. And so, first of all, it's very easy to do that. But also, if you change operators, it's a much easier operation because, again, you have like a contract as a reference.
Yeah, what I'm trying to understand is why Obol went that architecture, and you guys didn't.
So maybe dig into that, right? So what we've heard from Obol was that they wanted to avoid the overhead of a peer-to-peer protocol. And that's why they have single clusters, right? Because they don't really need to do any peer discovery and maybe respond to that.
Well, actually, that's not entirely correct. Like if you go today and set up an Obol cluster, and I can say that with confidence because that's exactly what we're doing right now, you'll have to set up a boot node for your cluster because of the way they set up discovery. And it makes sense because if you set up a static IP, if by any chance that IP changes, you're losing connectivity. So you have to have like that discovery mechanism. And so in reality, they did build a P2P network, but it's very single cluster focused. So one cluster has its own kind of microcosmos of a boot node, and then the clusters or the nodes working against that boot node and communicate with one another. What we adopted was PubSub, which is kind of a layer on top of it. It's the communication methodology used by the beacon chain, where you have the discovery, but you can segment which messages you want to get as a node. And so you can have those, so you can have a lot of different clusters built, but you don't need to listen to all of their messages. You can pick and choose kind of, if you, again, reckon back to how the beacon chain works, a beacon node doesn't listen necessarily to all of the different attestations every single epoch. It selects which attestations channels for the purpose of the explanation it wants to listen to. And so it kind of goes the same way with SSV. Your operator or your node basically makes a decision which type of clusters they want to listen to, and then get messages from that. And so I think that Obol went that route for simplicity. But in reality, the problem it creates is that it's great for one single cluster, but if you're looking at most real world scenarios, for the most part, it's a multi-cluster world. So that's kind of the reason why we chose to do that.
Does it also give Obol the opportunity to not have a token, or do they already have one? I don't know, but
look, I mean, it's anyone's guess. I would guess they will have a token, but who knows?
Okay.
I guess we've already looked at that. That's another kind of point we wanted to do from the get-go is be validator agnostic, that is, support both new and existing validators. That was really, really important. We have a couple of different DKG implementations in the work. Kind of the Dream DKG protocol we're working on is a zero coordination one. Basically means that every SSV node will be DKG ready. That will take a bit of time, but there's other kind of manual things in the pipeline as well. And change operators is also possible on SSV, which is it's important. Like imagine if you have like one of those operators, gets knocked down, gets offline, gets hacked, gets bankrupt, whatever the scenario you want to choose. Being able to change it is pretty significant, and it's something we're proud we support.
We might want to
going back
for a second, maybe, because we used a lot of acronyms here, right? So DKG,
distributed key generation ceremony.
Right, so a new key, right?
DKG is a new key. It's basically the idea that you can generate a valid validator key without any one of the participants in that kind of ceremony actually holding the final key. Rather, nobody will ever hold the full private key. But the result of it is that each one of the operators in the cluster you chose will have a valid share. So they could, through the DVT protocol, actually execute duties. Yeah.
And when one of those operators goes down hard and they lose their share, what happens then?
So losing in what scenario? So did they lose it because
they didn't make backups?
Their database got cleaned out? Did they get hacked or anything else? Like, depends on the scenario.
Sure.
Again, in our case, we have data availability on chain, so they can't lose it, but they might be compromised. That's another possibility. And so you could have a change of operators. You basically need to go through a resharing of the DKG and then change operators.
Got it. And existing validators, that's if I take my existing signing key and then what?
Split it up. Yeah.
And split it up.
You can basically store. Yeah. You could store it in cold storage, and then the shares themselves are assigned to whatever cluster members you choose.
Okay, thanks.
That's really important, by the way. If we
And
Yeah, go ahead.
how does the process work? Like, how do I connect with my group of people that I want to create a key with? Like, is that
Yeah.
process, does it need to be, like, do I need to be physically together, or because if it's
No.
online, um,
So depends on the method you choose. DKG is an interactive protocol, so you need some kind of an interaction with the others. But if you're using an existing key, then it's a completely passive thing you can do in an offline machine hidden away in the mountains. You don't need to interact or talk with anyone.
mhm. Okay, thank you.
Alan, there's
Supporting
a question
oh, yeah,
in the YouTube.
yeah. No.
There's a question in the YouTube chat. Can you set up a validator on can you set up a validator on a mixed set of nodes running SSV and OBOL clients?
If Obol wants to be compatible with our spec, then you could, but currently, not really. I wanted to say that supporting existing client validators is really important if we want to get to that 67%, 2/3 of the Ethereum stake being managed by solo stakers in DVT, because obviously there's 500,000 validators already in existence. So if you don't want to, like, it's a very important thing to support that. Yeah.
Right, to avoid having to go through the exit and then entry queue again.
Not just to avoid it. Many don't want to do that. Maybe
Right.
They're good at staking. They don't want to go through an exit. In terms of kind of the way SSV operates, so SSV is a DAO-based project, a community-driven project. So on the one hand, we've been very public with our testnet, been running a testnet for 18 months. That's significantly longer than any other DVT implementations. And it's a community-driven project, which means there's a lot of checks and balances which are not me, for example, or not my immediate team. And I think that's important to this kind of type of project. You want to have the ability for a community to make decisions, and for the community to single out issues, and for the community to make to check that things are happening in a good way. And so I think that's something I'm looking at other projects. I think it's challenging on the one hand, but projects that get it right enjoy, I think, a lot of credibility from the kind of wider community, because there's no, again, single points of failure within kind of the way this project behaves. And so it harkens back to having more than one client, but it also means that there's the centralized entity being able to, and with the resources to continue development, and it doesn't depend on a for-profit company. It means that if you have protocol-specific parameters you want to set up, then it's not, again, somebody just deciding on them. It's a community-driven effort, and so on and so forth. And so I think that's worth noting. And in terms of the use cases, again, very, very varied and very kind of dynamic. We're hoping, again, to focus on developers with the hopes of trying to turn as much of the existing validator set to DVT with a wide variety of operator nodes, but also, of course, new validators coming in and new protocols and so on. So that's kind of a lot of our focus, a lot of where we put our efforts. And to that goal, we really encourage people to kind of come and build. So about a year ago, we started out with a grant program designed to have projects come in and kickstart their development using the DAO's funds. You'll see two of them today in a few minutes. And that continues on to kind of getting the help of professional VCs to kind of invest in an ecosystem fund for those types of projects building on SSV. I think that's very important. And if we can see more and more of them, I think that it will kind of increase the overall DVT adoption, which I think is a crucial thing. And yeah, that's kind of the ecosystem map for SSV today. And we actually brought two great companies, two great projects building on SSV, each one with kind of its own flavor of how they look at staking. And yeah, I'd love to, friends, if you wanna start.
Well, do you guys also want to introduce yourselves? We've got Hendrik, Wildhair, and Stefan, I think.
Yeah, maybe I can start. Can you hear me?
Yeah, can hear you.
So my name is Stefan. In my daily life, I'm the CTO of Avado. So we provide staking nodes to the community already. But in this context, we are talking about Friends, which is a project that we've created in Bogota during the hackathon on DevCon. So that's me. Maybe Hendrik, you can take it away.
Yeah, can you see my screen in the meantime?
Yes, we can see it.
Okay. Yeah. Hello. I'm Hendrik. I'm also part of the Avado team and the Friends team. And so Steve, you're also here. So Zerix Wildhair.
Yeah, I'm Steve, 0x Wildhair. I am a smart contract dev on the Friends team, and excited to be here.
And then we also have people in different time zones who couldn't make the call. So there's also David and Norman. And here you see some pictures of us from ETH Global in Bogota, where we made it to the finals with the Friends project. So it was great fun there, and it was also really proud that we could continue this project of staking with Friends. So Friends' mission is to enable groups of friends to start staking Ethereum and run validators in a fun and easy and secure way. So you might ask, why do we need another staking solution? Because there are already so many options, going from the gold standard of staking, solo staking, all the way to custodial staking on central exchanges. So why do we need more options? So it's not a linear spectrum, of course. There's many choices that need to be made. So there's centralized staking. It's easy, so the end user doesn't have to make many choices, but at the same time, that's also risky because lots of things can go wrong there. At the same time, you cannot mess it up yourself. And then there's also entry cost of entry, like how much Ether do you need to start staking? And for solo staking, that's a quite steep hurdle. And also there's a very little social aspect in staking. You just deposit some ETH in a central pool, and then there are some communities like EthStaker and Rocket Pool, I know myself, but that's still something else than just staking with your own friends. So as friends, we also picked our choices on what we wanted to do with staking. So very important to us is having a social aspect there. So you stake with your friends. Also, the cost of entry is lowered because you can pool with friends and then put in less of a share each. Also, we want to make it as easy as possible, and that's where the Friends team magic comes in. And we want to reduce the risk by having a smart contract. So as friends, if you have good agreements, you can hopefully stay good friends. And so their smart contracts really help. Also, the DVT technology really helps to reduce risks then for the operator running the validators. But of course, there's still some trust, but you're a team of friends, so that's okay, I think. And then we also want to help the decentralization by having many small pools. So this is a quick sketch of what Friends looks like. So Friends is not a pool, it's a pool factory. So one of the Friends is the Friends operator, can go through the Friends website, call the smart contract there to spin up a new pool. And then his friends can put Ether in that pool through, again, the same user interface we provide. And in exchange, they get an NFT, and then later on the rewards once the validator is running. And then we also provide easy UI to spin up the validator and get SSV running. So Stefan, maybe can you guide us through the demo?
Yeah, sure, of course. So instead of an actual demo, I just took a number of screenshots because obviously going through a full-fledged demo with all the transactions and so forth would take us too far or would take too long. So I will just quickly go over the functionalities that we've built. So first, the first page that you will see on the test applications that we now have is to create a pool. So first you have to connect your wallet, obviously, to your to the application itself. Then the second part, if we can go to the next slide maybe, is to create the actual staking pool. So it's just like one simple button which will deploy the new pool, as Hendrik said, using the factory contract. And then once it's created, you will receive a specific link which you can invite your friends. So you can just send this link around to people that you want to have participate in your pool that you created. So on the next slide, we see...
Is it trustless? Like, can I invite anyone or just trusted friends?
So the idea is that only those people who you share the link with will be able to deposit in that specific smart contract that you deployed. So that's the idea. But for the rest, there's no limitation to how many friends you can invite, or you can just like do it with one friend. I don't know if that's the answer to your question.
Like what's the point? Does it share the rewards, or why do I pool with other people?
Yeah, so I'll go through the demo, and then I think it will be clear what it actually does.
Okay.
That's fine. All right. So next, the person that initiated and created the pool will be shown here. So that's also the social aspect. So we pull up his ENS information if he has that, including his avatar. And then you can select how much ETH you want to deposit in this specific pool. So you can just like type in any amount, and you can do the actual deposit. Then after you've done the deposits, as a reward or so as an exchange for doing the deposit, you will receive a NFT, so which is just a generative SVG minted at the deposits. And this allows you to also claim the rewards and also claim your deposit back later on if you want, if the group of friends decides to exit the validator. Then you can watch as the pool fills up. Once the pool is filled up, you can actually start your SSV validator. Right now, it's the operator's task to actually generate the staking keys. But as we heard before, there will be other ways of like doing that with DKG solutions later on. But for now, people have to create those things themselves. Then you have to upload to the deposit file of the staking key that you've created. Also note that the withdrawal address of this specific deposit key is the smart contract, the same deposit pool contract that you've created. So the rewards can only go there, and the withdrawals can also only go there. So then you upload the deposit file. You can immediately deposit your 32 ETH from the contract right to the beacon chain. So there's no risk that the operator might fool one of the participants and send the ETH somewhere else, because that's programmed in the smart contract. And then the next part is to select the SSV operator. So the default modus of operation is that you will use SSV to run your operator. The idea is that the person creating the pool itself will run one of these validators and will select 3 other validators to actually run the pool. So after that is done, you can actually see on the beacon chain that the validator starts up. And then later on, so when everything is done, these NFTs that everybody has will be a tradable share. So here's now a view on the OpenSea. So if I'm fed up with this group, I don't want to be part of this anymore, I could even sell my share of that specific pool to somebody else. So you can clearly see what your deposit is, also the amount that you can claim, which are the rewards that are already sent to the contract. And these are implemented as custom NFT trades that update real time. So whenever there's like new rewards coming in, these trades will be read off chain real time, and they also represent your collateral. So that's where we are at right now. So why did we use SSV in our solution? First of all, for the fault tolerance. So as a solo staker, one of the things you want to avoid is to have downtime. The SSV as technology will allow, since like 3 other people will be helping you to do the validation of your validator, is that you avoid the downtime. At the same time, you also minimize the slashing risk, so you don't have to worry too much about that. As already mentioned before during this course, your validator keys can be kept offline. Note that, of course, the group of friends still needs to trust the operator, so the guy creating the contract here, but that might change in the future even. And even pools could run without a validator themselves. So you could also go for selecting 4 different SSV operators. In that case, you don't have to run your infrastructure yourself. But our preference is, of course, and the way we want to push it, is that everybody runs their own validator or at least operator for SSV. So yeah, our invitation is that you can try it out. We have a version running on the Girly network, so you can try it out and give it a test spin. So you can visit friends.fun. We'd also love to have some feedback on what we've already built. If there are other features that people are missing, we have a Discord set up, so we all invite you to join us there. So this is Friends. I don't know if there's any questions.
Thanks so much for walking us through it and showing it to us. If nobody has any questions, we can introduce Stater Labs. I think from Stater we have Amit, Vibin, Sid, and Antonio. Did I miss anyone?
No, I think you have covered all of us, Nix. Can we start, or should we wait for any questions?
It doesn't sound like anybody has any questions for Friends, so why don't we go ahead and start?
Awesome. So let me share my screen. Yeah. Firstly, thanks a lot, guys, for having us here today. Very excited for the conversation, and thanks, Friends and SSV for great conversations earlier. Quickly introducing Stater, we are a multi-chain liquid staking protocol. Started our journey with Terra 1.0 about a year ago, and managed over $1 billion of assets before the Terra's collapse. And we managed to scale through 6 other chains after the collapse and have about $100 million today, and over 70,000 total stakers over lifetime of Stater, and we have a 160K plus community members across the chain. Currently, our liquid staking solutions are live across Polygon, BNB, Phantom, Hedera, and Hedera Terra, as well as Nia. And the reason why we are here today is we're coming to ETH soon with our EthX liquid staking, and going by the ethos of crypto, which is decentralization. We have always preferred delegating to smaller and lower voting power validators, because we want to encourage decentralization, and that's what we have done across the chains that we have launched our solutions on. And we have actively encouraged validators that have supported the community across the chains. Right. So let me talk about how we have thought through EthX design. EthX is the liquid staking token that we are launching on Ethereum. So the entire EthX design is made in such a way that the home stakers are the backbone of the overall solution. I will go deeper into the overall technical architecture, but let me cover the most important aspects here. The way ETH staking is designed is completely non-punitive to any general mishap for node operators, right? Unless and until it's a full-fledged attack, ETH staking, slashing, etc. is is very, very non-punitive. So we think 4ETH bonding to begin with is a sufficient enough bonding to launch a node operator on Stader's ETH solution. This is by and far the lowest in the ecosystem, 1/8 of the actual ETH staking minimum requirement, which is the 32 ETH. What that means for the home stakers is it results in significantly increased earnings with a much lower capital requirement. And ETH is designed to be permissionless right from day one. Right. Coming to the way we have designed the technical architecture, we want to add scalability and resilience to the backbone of home stakers. What that means is we have a hybrid approach with the permissionless pool as the main pool of validators, where anybody can start running a node with us and receiving delegations from ETH contract by bonding 4ETH. We also have a permission pool of validators where there's no bonding requirement, but this helps us scale the supply to a significant amount commensurate with the demand in case there are supply constraints with the permissionless pool, right? So this kind of architecture, what it helps with is obviously we get scalability right from day one, at the same time encourages decentralization. We believe this kind of architecture encourages decentralization because of the benefits that I highlighted in the slide above, which is much lower bonding requirement and much higher potential for earning, right? Now take this and then add DVT technology on top. It just turbocharges the home stakers and creates infinite supply from permissionless pool. Because we believe the DVT technology and obviously our friends here, SSV, have done a great job at it. Once we switch to the DVT architecture, the minimum bonding requirement can probably go to very close to 0 levels. What that means is obviously anybody can just plug in a node with very, very little capital requirements and start receiving delegations with Stader. We have run deep data assessment with data sets running over the past few months to see that users' funds are not at risk despite these lower bonding requirements. So all of those analysis is what we'll probably share in the light paper that we are going to launch in the next couple of weeks or so. Yeah. Why SSV? Obviously, we have covered this in the presentation that SSV friends have given earlier. This improves the fault tolerance and also catalyzes the growth of home stakers. As I mentioned already, now with much lower capital requirements to start running a node, this could potentially scale the supply side, which is the home stakers, to significantly larger levels compared to what it is right now. And I think this can really catalyze the growth of decentralization on ETH staking specifically. Yeah. Now, obviously, none of the liquid staking is complete without DeFi. Today, a lot of decentralized liquid staking protocols struggle with encouraging DeFi and struggle with the demand side because of prohibitive commissions. So our commissions will be competitive. At the same time, with the deep expertise that we have built, cultivating DeFi ecosystem around liquid staking across the 6 chains that we have present in and 40 plus DeFi integrations that we have built across the chains. Obviously, our liquid staking derivative on ETH will have a full-blown DeFi ecosystem so that users don't have to choose between decentralization and DeFi. So we will bring a combination of both of these to the ETH staking derivative community. Yep. So that's where I want to kind of end it. So we have a hybrid architecture with permissionless and permission pool, really bringing down the capital requirements for the home stakers and turbocharging their earnings. At the same time, not compromising on the scalability with the permission pool. So all of this with the combination of DVT technology and SSV can amplify these factors further at the same time ensuring that we have a full-blown DeFi ecosystem around our liquid staking derivative.
Sweet. Thank you so much for sharing, Amit. Does anybody have any questions for Stater?
I have a question for Elon, if he's still here.
Yeah, of course.
It might be a mean question, but so there are like 500,000 validators right now, and there have been 200 slashings over the last 2.5 years. And so I would argue it's quite safe to not use SSV. And since SSV just adds another layer on top of it, wouldn't we expose ourselves to a new risk that, like, why should we use SSV if staking as usual is already safe enough?
I don't think that's the focus. I think the focus is looking at the systemic risk on Ethereum and looking at the state of centralization of stake. And ultimately, you know, risk is probability times the effect or the cost of an event happening. And so it's not necessarily looking at individual risk of getting slashed. I think that you're right, it's pretty low. I think it's looking at the larger picture. Ethereum staking is fairly centralized, and it poses a great threat, I think, on the Ethereum ecosystem. And I think DVT is a major tool for decentralizing it and trying to solve that. And so that's how I look at DVT in general. Sure, you have greater slashing protection, but it's not that. It's definitely not a better slashing protection. It's fundamentally changing who holds the key and what happens if that key is compromised. That's the bigger picture, I think.
Okay, fair.
Any other questions we got for any of the teams, Friends, Data Labs, or SSV? Awesome. We will wrap up then. We will drop the POAP link in the YouTube chat. Remy, you got that?
Yes, it's just dropped.
Okay, great. And we will also drop the Discord link for SSV and any docs that you guys want to maybe send. A couple of people in the YouTube chat asked for resources on how to read up on SSV. One last question. Is there a way that regular stakers today can get involved and keep up with SSV?
Oh yeah. Well, first of all, you can go to our website or join our Discord. The links inside the website. We have a lot of solo stakers and at-home stakers on the testnet today. We had a lot of DApp nodes and other solo stakers running nodes and trying it out on testnet and hopefully later on mainnet. And so yeah, it's a permissionless network. You can definitely join in both from the validator side, but also from the operator side. Just run a node. And so yeah, visit us at ssv.network and yeah, reach out.
Remy, one thing, the POAP link, you can't drop links from your personal account. It has to be from the EthStaker thing, so people can't see the link that you dropped.
All right, we'll post the link in the description of the video.
Perfect. And then we'll make that available for just like 5 or 10 minutes after the call. Cool. Thank you guys so much for coming. Thank you for showing your projects and answering questions, even if they're mean or hard.
Thank you for hosting us. Thank you.
Thank you, guys.
Right.
Thanks a lot for hosting us.
Thank you, everyone.